Welcome back to our channel. I'm teacher Cedric. Now the NMOS exam is coming soon, and we have received a lot of questions from our students. For that, I would like to share one of those questions with you guys today. Let's have a look at these questions from the NMOS 2015 Special Round Question 17. It is known that u and v are whole numbers and that 2u plus 3v is not more than 100. Find the largest value of the products of u and v. We are given the sum, and to find the largest product of the two numbers, there's a rule of thumb that we can follow. But before that, let us have a look at a simple example first. Now, given that a plus b is 10, what is the maximum value of the product of a times b? For that, let us have a look at this table. When a equals 1, b equals 9, the product is 9. When a equals 2, b equals 8, the product is 16. And the list goes on, and we see that the maximum product can be obtained when a equals 5 and b equals 5. So we can notice as the two numbers get closer to each other, then the product would also increase. And at which point we can obtain the maximum product. That is, when the two numbers are equal to each other. So from this table, we can conclude that if we want to maximize the product of two numbers, then first we have to minimize their difference. Well, of course, you can prove this rigorously by using the difference of squares formula, but that's another story in your secondary school. And there's a premise or a precondition to this conclusion. That is, the sum must be fixed. For example, we can see that 1 and 9, so that the sum is still 10, 2 and 8, and the sum is 10, so that the sum is always fixed throughout this process. Now, with this in mind, how can we solve this problem? Let us first write out what we know. We know 2u plus 3v is smaller or equal to 100. Now, in order to find the largest value of u and v, u times v, let us first ask ourselves this question. Is the sum of u and v fixed? And the answer is no. There are many possibilities here, and we cannot guarantee the sum of u plus v. But instead, let us have a look at this equation more carefully. For example, if we want to achieve the largest value for u times v, one number I should put on this right-hand side here. Well, we would like to put the number 100 so that we can get the maximum value for u and v. So we see that even though that u plus v, this sum is not fixed, the sum of 2u plus 3v is always fixed under the maximum condition. So instead of looking at u times v, we can have a look at this equation here instead. We know the sum of this number as a whole and this number as a whole is fixed. And to simplify things, let me denote 2u as x and 3v as y. So that now we have x plus y equals or smaller than 100. And in the maximum case, this would equals to 100. So that the sum is fixed, then we can try to use the thing that we just learned. Now, in order to maximize the product of x and y, then naturally, we will want to minimize the difference of x and y. And that gives us this case, when x equals 50 and y equals 50. But let's check if this case is possible. Is it? The answer is no, because y must be a multiple of 3, because y equals 3v. But 50 is not a multiple of 3, so we know this case is not possible. So next, let us try to find the closest multiple of 3 to 50. That is 51 and 48. And when y equals 51, in order for the sum to be fixed, then x must be 49, so that they add up to 100. And when y equals 48, then x must equals 42, so that again, the sum is 100. Let's check which of these two cases are possible. If we look at this case, 51 is a multiple of 3, which is good, but is 49 a multiple of 2? The answer is no. So again, this case is also not possible. But what about the third case? 48 is a multiple of 3, and 52 is a multiple of 2. And they add up to 100, and they are the closest multiple of 2 and 3 to 50. So that we know the largest product of x and y would be 52 times 48, which corresponds to u equals 26 and v equals 16. And voila, we have found the largest value of u times v, which is 416. So to quickly wrap up this question, we have learned that in order to find the largest value of the largest value of the product of two numbers, in order to maximize this product, we need to minimize the difference. And there's a precondition to this, is that the sum of these two numbers must be fixed. And in the case where the sum is not fixed, for example, this question, then we have to turn an unknown problem into a non-problem. For example, u plus v is not fixed, but 2u plus 3v is fixed. So instead of focusing on u and v, we should try to focus what is the largest product of 2u and 3v. And from there, we can get the largest value of u and v. Now, if you want to learn more about NMOS, RI, or SMOPS exam, make sure you follow us on our WeChat or WhatsApp group. And if you do enjoy this lesson, please consider to subscribe, like, and share this video with your friends. I'm Teacher Cedric, and I'll see you soon.